Hi there, this is Kieran Oversapian for Filmstorm, and thank you for taking the time to evaluate our motion matching plugin for Unreal Engine. Upon loading the project download, you'll see that we have this scene, and if you press play, you'll notice that the project is working from the start, and essentially the motion matching plugin is providing all of these animations through what we call the animation analyzer, which is these modules down here. So if I press stop, and we'll just go through this. So basically the way to start the analyzation of the motion matching is we need to basically make a state of the different animations that we want to actually capture. So if we right mouse click down here and we go animation, you'll see we have this new node in here called animation analyzer. And basically, as it says, adds the animations for motion matching system to analyze the motion data. So if we click that, we'll need to specify a skeleton. So in this case, we're going to be using the default mannequin. And we'll need to select some bones for the motion matching system to like reference and grab the data from. In this case, most of the time, you'll just want to select the main bones. So you don't want to have any fingers. You'll just want the hands, arms, main spine, legs, and feet. So, and you don't want to select any equipment nodes because, unless you want to reference them, but most of the time you just want to reference the actual body. And we don't want that hand, that finger. So we'll come down to clavicle and we want to select between here and the hand. And then we'll select the neck and then the thigh, foot, ball, and the calf, avoiding the twists. Twists, they usually spin a lot, so it's going to give inaccurate information. So just try to stick with those main bones, and no IK nodes as well. It seems to provide the best results. So if we say accept, it's going to give us a new name selection, so we can just say jog just for now, and double click on that, and then you'll see this new little window pop up, which is asking us to add some animations. And this is basically just a container, and it's going to do all the calculations in the background to analyze everything. And if for some reason you can't see this, there's a known bug that we're fixing at the moment. But if you just drag this toolbar, the details will pop up. So pop that back there. Okay, that's just a quick fix if that's not showing for you. So let's just go add animation. And once we click that, it's going to populate with different animations. And let me just type in jog. And as you can see, we have these different states, and I'm just going to select down to the bottom, except I'll just take out these few MG ones. I don't want MG, I just want these ones. MG is for machine gun. And then once I click add, it's going to just quickly go through and analyze all of those frames in the background and hold that in an array, which will then reference when the game is being run. So now you can see we have all these animations. And then you can always come back if you're getting too much information or there's too much difference. You can always take out some animations and play around with it to get the best results. But essentially, the kind of animations that you'll want to be capturing are long take animations. So if I come to like a jog, you can see that we have, it's basically, this is going to give all the information that we can get because he's basically spinning tighter and tighter in a circle. So, I mean, if you're doing this with sword animations or more aiming animations or running with guns and stuff, basically you just want to mimic what kind of these takes are, because these have been tested over and over with different like variations when we were recording, and all of these gave the best results. So if we just close that. Okay, so now that we have our animation analyzer filled with these animations, how do we use this in our blueprint? So let's go over to animation, and down here we've got our anim blueprint. And let's just pop this open. And we'll come back to the event graph when we just talk about the inputs. So in our anim graph, you can see that basically all we're doing is we're just grabbing the input data, which is basically just which way is the player pushing. And we're just grabbing that and converting it to like a route prediction data, which is a special data type for the motion matching. And as you can see, that is basically just and in velocity with direction inputs. And all we do is we click on our Filmstorm motion matching node, and up in our animation analyzer, you'll just want to select which one we're using. So in this case, let's just switch over the default rifle locomotion into the jog. And basically that's going to we're just storing this into a create new pose, or a new save cache pose. And I've just named that, so then we can reference that back in the state machine. And basically these variables you can tweak. So the reaction speed to the player's input. Basically, if you want more reaction, you can pump that up faster, but you'll get more of a straight cut in between the animations. You won't have that nice blend, which the motion matching provides. The blend time, how long you want the frames to blend between each other, between the referencing animations. Play rate, that's usually set at 1, because you can pump up the animations in the actual animation settings. The time that takes between blends, so if it's going between a start and a run, this is the 0.2 frames between that blend, and the max amount of changes, or the amount of frames that you want to reference, or different animations you want to reference per frame. So that's potential finds of the frames that will be located. Okay, so this is being stored into that pose, and then we basically come into our state machine, which is super simple because all we're doing is we're entering, and we're just going straight into our locomotion one, which is essentially that same pose that we just cached. And even in this pose, that's the only thing that's driving all of this movement. Hang on, let me just do a new editor window. So just from that quick setting, we've got all of these animations already running. And if I grab my controller, I can really start to push forward, and you can get even more movement. It feels a lot nicer when you use the controller. He's kind of doing this funny mid-step because we actually have we have a slow animation and a fast animation in there, but you can tidy that up. And then essentially we just have our normal fall. I mean, you can basically customize this as you would with any game. You can build this out into your own systems and machines, depending on what you actually want to achieve with your game. So as in the example, we have a crouch, so you can press C and then we'll reference this other cached pose of the crouch, and aiming with the right mouse button, and it'll bring up the aiming. And this is all just driven by simple bools in this case, but of course you can do layered animations on top of this as well. So you can have aim spaces on top of the aiming, and that's not going to affect the motion matching at all. So that's basically how the animation system is set up. And you can have as many of these as you want. You just keep coming down, look for motion matching, bring that in, and then do what you want. So let's talk about how we calculate the root prediction data. So let's just compile that, close this, and let's go over into our third person CPP, blueprints, third person character. And you can see that I've set this out as neatly as possible. We have our beginning, we have our get rotation and position for the goal. So if we just jump into this, there's basically 4 macros. The only 2 you really need if you want is just these 2. Essentially this node for the rotation helper is basically what that is. It's a rotation helper. It helps keep the rotation stable, and because motion matching sometimes finds weird rotations right when you're finishing. So this just helps when you release the key or the input, it will find that last frame of that rotation of the player and just set that. So it just helps smooth out that rotation. But we'll have a quick look at that in a second. So coming back here, we're going to get rotation, and all we're doing, there's no input because we're just starting off. We're just getting the control rotation, we're breaking that into a yaw, and we're basically just separating that between forward and right, and then we're just timesing that by each other and the forward, and we're tuning that by 1.5, so we get a little bit more forward than the right movement. And then we're just adding them back together, times that by the direction input strength, which we initially set in our construction script to 400. And basically, if you have a lot of sprinting, which has a big range of root motion distance, you'll want to set this higher. So, or if you're just having crawling or crouching, you might want to bring it down, and that will actually improve the responsiveness on the controller joystick or in the keyboard. It just helps doing. So if you're finding that the character is always running, you try bringing this initial value down a tiny bit or pumping it up if he's not fully getting into the sprint. So this is basically how strong that input should be. Okay, so going back into the input, so we're basically timesing that by the input, so that way when we push forward, it's going that further distance of that extra, like in this case it's 400. And now we are then going to plus this by the broken transform of our mesh. We're getting the world transform of that, and basically we're just separating, we're plussing that location with this input to give us these two outputs. So essentially this output is the world transform, which is just our generic mesh transform from our character, and this input direction transform is which way we're pushing. So, and then that way in the next node, we'll just jump over to that. So we're taking our input, which way we're pushing, and the world, what the character actually is, and we're just going to create that motion matching data. In this case, you can see we're just using an event tick. This can be replaced once you have other inputs. I mean, you could even drag one of these guys up and they'll improve in performance, but I just wanted to point this out that this is how we have it running right now. But you can adjust it, it will work exactly the same. So let's bring this guy up. And as you can see, we have the root world transform and the desired transform or input coming in. And using our motion matching, you can see we're creating the desired target. So this is basically which way we wanted to push. It's like our end position. So we're grabbing that desired input and the player's current position, and then we're applying that float again at 400. So that's how much we're pushing, just so the system knows that's what we're timesing that input by. It just helps with the calculation. And then we're just outputting the actual data, and then we're just setting that to our root prediction data. And now to help with the debugging, as you can see later on down here, this is just going to draw us that nice line when we're playing. So this green line on the ground, basically the straight line, and then the line that we were. So basically that's what all of this bottom part is. If you don't want to do that, you don't need to, but this is also helping drive our rotation helper, so it does benefit us in this case. So in this break, we just bring the direction down, we break it, we're grabbing that last index, so where the player was last, we're grabbing that, and then we're breaking that again just to grab that transform, and then we're just composing that with the current transform, and then we're breaking that again to give these two. So basically this is the input, and then this one is the world, because this one is the transform of that world's location. So basically that's the player's transform again, this is the player's current transform, and then this is where the player is actually inputting the push direction. So then we bring this over. This is just simple debug. I'm sure this is fairly self-explanatory. We've just got the current world transform, and that's all it is. That's just where we are right now. And then this is the second one. This is where we were. So just pushing in that direction. And then this is just the debug helping script on the side of this, the top left of the screen. And then bringing up to the rotation helper. So this rotation helper basically is getting driven by the branch. So the branch says, okay, if I'm pushing down, then we're just going to be setting this to whatever the rotation should be. Like for the motion matching, we're just going to let the motion matching do its thing, and we're just going to slowly ease that over to where that actual input direction is. So that way, if you're pushing straight and he's not quite lined up because the motion matching didn't match it perfectly, he'll just slowly reach that position, like when you're running over a longer distance. So he's not kind of running off on an angle. And I find that the one interp works the best for that. And then in this case, with this condition, it's true. When we release it, he's just going to quickly snap into that last known rotation, and then he's just going to hold that, and then it's going to finish and then blend back to the branch. So if we have a look at this one, so we're basically getting the forward and right again. This is pretty much the most complicated pro. Basically, all we're doing is we're just getting, so this is our forward, we're basically just getting this and also our right with the -1 to get the correct angle, and we're creating a rotation X vector, and we're splitting that with the delta rotator and delta rotator again to get the distance between or the angle between the follow cam and the capsule. And you can see we just got 2 get world rotations. And then we're just setting this rotation that we receive from that. So basically this is just what the rotation should be, what our current player's rotation. And then we're driving this, and then as you can see down here, we're just clamping this, so it's always between 0 and 1, just to make our job easier. So if our clamped value is less than 0.1, so if we've released the input, then this branch will be true, and we're going to do it once. And what are we going to do once? We're going to set the finished rotation to that current capsule rotation, which is essentially which way we were pushing our character. So we're setting that, and then when it is not true, we're going to reset it, and then it'll be ready to run again. We'll be doing it once again once we finish the input again. So basically then this finished rotation comes in, we move it over to here. The condition is also set from this. As you can see, if this is less than 1, then this position also comes through here into the rotation helper, into this condition, and then we're setting finished rotation to snap and keep the player in that rotation so he doesn't spin off at an angle. And this is just driven by get roll delta seconds. And that is basically it for the actual movement side. That it's like a super simple input direction. You can also maybe customize this for up and down, so you can be climbing or you can be going up and down ladders. With this input direction, you could maybe times this instead by to go up in the positive axis, like the up axis. So basically that's you can customize that with different nodes, and you can just blend between them like you normally would in your blueprint. Basic rotation for camera, and just our button handlers. So we just have our crouch. Basically, just you press it and it will just set the crouch either on or off. The aim either on or off. Just our jump. This is standard jump. If we're falling, then we set it, and if we're not, we're fine. And just a sprint, which I don't think we're actually using in this one. Okay, and then we just save that, jump back. Let's just jump back into the anim. And let's go into the event graph, just so you can see what we have in here. Super simple again, we've just got the normal event blueprint update animation, checking if it's valid to the pawn owner. We're casting it back to that player, the blueprint that we were just looking at. And we're just grabbing all of those variables and setting them into ones that our anim graph can read. So basically, we're just grabbing the direction input, we're getting the route prediction data input, we're getting the movement component and the falling. I'm just setting that if it's in the air. We're just grabbing all of the aims, crouches, sprints, and jumps, and we're just setting all of those. And that is it for the event graph for the anim. And basically that is all that is driving this. So you can see that we have that new jog. There you go. And just to show you that it's super simple to switch that stuff over, I'll just save that, jump out. Let's just go back to this jog, and we can come and take out the animation. Potentially one thing that we could include is a remove all animations, just to make it a little bit faster, because each time you press down it will reevaluate the animation analyzer each time. So as you can see, it gets faster and faster with each less animation. So let maybe do walk. There we go. I'll just grab these ones and select these. Okay, so that's finished loading. You can see that we have these all in here now. Let's click save. just going to save that to the system, and we can click play. And now you can see that we have our walking animation. You can see that if you start to move this way, he'll even look in that direction because that's what's actually getting referenced from that other animation. Alright, so that's a quick overview of the motion matching system for Unreal. If you have any other questions, please let me know at team@filmstorm.net, and I hope you enjoy it. Thanks for watching.